All right, today is the review. For what? For the polynomials test. You need to know so many things about polynomials. Yes. The polynomial that is in question here has got a lead coefficient that's really obvious. And it's got a missing term. Let's make sure you understand what that means. So what's the lead coefficient on this one? Yes. Yes, that is the whole lead term. And of that, which is the lead coefficient part? The -3. All right. And that tells you something about your graph. Can you tell me what it tells you about the graph? Do you know, sir? Yes, that negative in front is telling you something. It's saying something. It's whispering down. It's going down on the right. Unplug. Can't have those in when I'm teaching you stuff. Both of them. I need full attention. It's a review for the test. This is the big time. You need to be with me 100%. Yes. Okay. Could there be a trick? Well, so far I haven't done anything illegal. Let's say I said it was like this. Could you see a problem with that? There's a problem. I did not graph this right for sure. Now it is a trick. Yes. The y-intercept is supposed to be what? 3. But here it was actually a negative. So yeah, that could be tricky, but I haven't actually finished. So let me just finish this and let's see if, would that be a possible graph of it? Just because there's a missing term doesn't mean that that couldn't be the graph. So there is a missing term. And if I threw it in, and I put in, instead of this plus 3 here, I put in plus 0x plus 3, that would show my missing term. That only really matters, though, if you're going to factor it. That doesn't change like how the graph is going to look. All right, so how about this? It's up on the left and down on the right. Would you have known that that was going to happen? Yeah. That would say down on the right. What about this would say that the other end is different? Yes? The exponent is a 3, yes, and it's odd.
It's the opposite of the right side.
Odd means that it'll be the opposite or different from the other side. You're right. Okay. Now, what if I give you a different one that's in factored form? I'm going to purposely make it tricky. Nah, that's too tricky. I'm going to make it power of 3. All right. Imagine you had that one, and I said, what's the lead term and the lead coefficient? See if you can answer that part. Lead term, lead co. Lead term. Okay. You know anything about it? You did have a clue. You just weren't sure. That's good. That was right. All right. Why the negative? Mr. Johnson.
Because x squared is because when you square and if you cube a negative, then the negative is still negative.
You're right. That has to get cubed, and when you cube it, it's still negative, and that's why it's negative. I think so many people didn't even think about that. You're right. If that had been a squared, then it wouldn't have really been negative. Think about that. The negative would have got squared away, and it would not have had a lead term that was negative. So you're exactly right. Okay, so now, can you sketch for me what this one would look like? The negative means down on the right. You know where it touches. Now, I know some of you are like, so should I use 7 or -7? Well, would you agree that negative x plus 7 needs to equal 0? If I subtract 7 from both sides, I have negative x is equal to -7, so x equals 7. Positive 7 is the root. That's what would make this 0. See, look, if I put a 7 in there, see? I know that some of you feel like that negative is a part of the x, and it's not. The negative is in front of the x. So x is 7 is the root, so it hits at 7. Hits right there. and it does that weird, funky triple root thing. It also hits at, what's that telling you, positive 1 or negative 1? Positive 1. Hits at those two spots, has to be going down on the right, has to be doing that weird triple root thing. So here's what that weird triple root thing looks like. And then it has to be just cutting through at this root. Like that. There we go. Now, does that match up with this x to the 4th thing?
Why not?
You don't think it does?
No, it does.
You think it does? They're both going down. Is that what you'd expect? From up to the 4th? Yeah, they should be the same. Okay, and this negative in front, is it fixed? Is it like matching up with that? Yeah, it's going down on the right, so it's got that going for it. All right, so there's my graph for this one. Say it one more time. It will look kind of like that. Now, exactly what it would look like, if you want to know without any stretch factor what it for sure looks like, you could put that exact equation into Desmos and just see what it looks like. Go ahead. Oh, did it have an extra like little loop in it or something? Okay. But again, you don't have to know that. What you'd have to know is how does it touch here? It's got that weird looking curve to it. How does it touch here? Straight through because there's only a 1 there. What's it doing on the right? It's going down because it's negative. And what's it doing on the left? It's going down because this has a power of 4 for its degree, so it should be the same on both sides. Okay. Whew, so much stuff to know, and we haven't even started. You ready? Everybody try to factor this one. 4x to the 4th plus, let me think, 6x squared plus 4. That will factor. As long as you take the prime directive of factoring into account, which is that you always look for something first. What do you look for first? For some of you, it's snipe. You're always looking for snipe. It's always snipe hunting. Some of you are hunting for the GCF. That's what we're hunting for. The 2 goes into everything, and then you have 2x to the 4th plus 3x squared plus 2. And I am pretty sure that I forgot and messed up a negative on this. And I apologize. There should be a negative somewhere. Does anybody know where the negative should be? Yes. I think it's a -2 at the end. And that means that that number should have been a -4 to make this all work out right in the end. So now, why? That was a good question. Because it should be 2x squared and x squared. And I need 1 negative and 1 positive. And 1 2 and 1 1. In order to make that work, here's all the pieces I need. I need a 2, and I need a 1, and I need a positive, and I need a negative. Now, if I put them in the right spots, that'll work. They're not in the right spots right now. Okay. So, we get this far, and then Mr. Server sadly has to say, you're going to lose part credit. Can anybody find the part that isn't factored all the way? In the back, sir. Mm-hmm. Holy cow. Now I'm finally done. It's not factored yet. 2 times 2 is 4, and that's not even what I'm talking about. Do you get that that can factor further? Factor it the rest of the way, including the kind of factoring you can do if you involve I. Because I'm positive that you will need an I to factor this positive 1. Factor it all the way. This is complicated stuff, but hey, you're in an honors class, and I think you're almost all going to do it. You're all going to get, not all, almost all going to get an A or a B on this test. It's just not easy. Yes?
Don't put two to switch up there because otherwise when it's
Let me double check. Oh, you're right. I never rearranged that right before I factored that 2 out. I apologize. I was saying we needed to get this factored, and I'm so sorry. I was supposed to move these around into different spots and stuff. And I was just letting you figure out where to put them. Ah, my bad. So, you, sir, did you ever notice where we should move that to? Regular x squared, so it should go there? And should it be positive or negative? So that's all I needed to do to switch it? Okay. Now, how do I know you're right? I know you're a smart kid. I can kind of just trust you, but I really shouldn't. That times that makes 2x to the 4th. Is that what it's supposed to make? Yeah. That times that makes 4x squared, but then you include it with this, which is a minus 1x squared, makes 3x squared. Cool, I got those two parts, and the last thing I got to do is check that, and that makes negative 2, and it worked. Awesome. So now, turns out, we don't have to factor out an extra 2. That was making me a little confused, because I was looking back at the original going, there's no 4 in everything. Why can I factor another 2 out? But we couldn't. So if you had this, I'm a little concerned that some of you are not going to be able to pull off the complicated factoring that we need for these 4 parts. I know lots of you can handle this, but stretch yourself. See if you can handle that one. Give it a try. I'm going to pause for a second while you give it a shot. Okay, so I hope that you were able to figure out this one. This one should have been the easy one. X plus and x minus, and this is I, and this is square root of 2, and this is I, and this is square root of 2. How did I know there's going to be an I? Because of that positive. Because if you put something in here and you square it, how could it come out negative? It couldn't. It's trying to make this whole thing equal 0. The only way that can work is with the imaginary I, which gets squared and gives you an extra negative. Okay, and then this one, who all got that it was an X and a plus and a minus and an I, but there had to be something else. And you're right, there's not any I's. Dang it, this one's a negative. You're right, those aren't I's. What are they? Those are 1s. Sorry about that. I need a plus and a minus, and it doesn't matter which one's which, but let's go with this. They're 1 and a 1, but there's still something wrong. Yes? All right, so if we put a square root 2 here and a square root 2 here, now let's actually make sure that works. Now, how can you know it works? Because you check. This times this, that makes 2x squared. That's what it's supposed to make. Outside and inside, do they make opposites of each other so they cancel? Yes. And then the positive one, the negative one, they make negative 1. Sweet, I know it's right now. So there we go. Square root 2x plus 1, square root 2x minus 1. And I know that's where some of you guys are going to lose your A, because you won't be able to handle that part. I think some of you can get it. I think a lot of you can get it. Okay. So this one had 4 imaginary roots. I want you to think about what that means. That means it never touched the x-axis, because imaginary ones you can't see, they don't touch. And it crossed at, where was it? Let me look up here. Negative 4 was the y-intercept where x is 0. So negative 4, it had to hit down here and never cross. Do you get that means it had to do something like that? All right, pausing for a second. Okay, so all I was trying to say here is that since they're all, dang it, they're not all imaginary, Mr. Server. I thought they were all imaginary because I put I's here in the first place. They're not all imaginary. These 2 are imaginary, and these 2 are real, so it, my bad. It does touch. And where does it touch? These can be solved to tell me exactly where it touches. And where does it touch? wherever root 2x plus 1 is equal to 0. Subtracting 1, root 2x equals negative 1, divided by root 2, divided by root 2. That's where it touches. That's some nasty decimal. Now, we're not going to give you anything that difficult. So let's get one that's a little more like what you'd have to do. Everybody try this one. X to the fourth plus 3x. No, let's make that to the third. Make it a lot easier. To the third plus 3x squared plus 6x plus 18. This one, factor by grouping. Go. So many kinds of factoring. That's why I was really happy that we had time to do 2 days of review for this test. So I'll pause for a second. Let me give that a try. All right. Did you notice that x squared came out? X plus 3. Did you notice that 6 came out? X plus 3. And then if I factor out the x plus 3, what's technically happening is both parts are getting divided by x plus 3. And then what's left? Could I stop there? You could stop there. But would it be smarter to go on? Yes. So you could go on and make it these imaginary roots. X plus and x minus. Square root 6, square root 6. And I'm positive you will need an I. There we go. Yes?
Would you get points if
2 square root 2. I'm a little confused. Where's the 2 square root 2?
no, because like the case.
Oh. Do you mean this square root 2? Or the square root?
Yeah.
If you didn't have a square root there, I don't know how else you would do it. Like, you can't just use regular 6. Because if I use regular 6, 6 times 6 would make 36, not 6. You know what I mean? You would definitely need that square root. Otherwise, if you don't use a square root of 6, it won't work. Because the reason I know is because you have to multiply it back out. And this times this would not make 6 unless those were square roots of 6. Otherwise, because this would have to be a 36 to use regular 6s.
If like the square root was like divisible by 4 or something, would we get points taken off if we didn't simplify the root?
Let me act like you're checking over your test and you're at the end and you just did this. Should he be worried or not? Yes, he should be worried. Why? Because you can simplify that. So you got to be able to simplify that square root. Now, it'd be even more obvious if I used like square root of 16. Then you for sure are going to lose points because that should be obvious that that's just 4. I do get kids that do that all the time, but you're right. It's kind of sadly a way to lose some points. So this one, you'd go, oh, crap, there's actually a square root of 4 in there. And then you'd say it's 2 root 3. 2 root 3. That make sense? Okay. Yes? I'm sure you can. Yes, you may. All right. So how about this? This one, let's do synthetic. X to the third plus 3x squared plus 9x plus 27. And let's do synthetic on this puppy to see if you remember how to do synthetic. I'm pausing for a second. Let me give this a try. Now, I did do this in each class. I had one that didn't work. Now, I actually, honestly, was expecting this one to work. But you should have this happen at least once where you go, wait a minute, this one is not working. And you're right, it doesn't. Let me show you. And you'd multiply, and then you'd add, and then you'd multiply. 6 times 3 is 18, and then you'd add 27. And then 27 times 3, what? It's not working, but you have to finish to prove it. you'd have to say, no, this is not a factor. And then you do, so that'd be 60, 81. Did you get 108? 108 is your proof that you did it right, and yet it didn't work. Okay, so you're right. But I did mean for this to be -3. So everybody try it again with a -3 and see if -3 works. All right, let's see if you did this one right. The drop it like it's hot is one of the hardest parts. Then you multiply, then you add, then you multiply. Oh, it's hard to multiply by 0, isn't it? And then you add, and then you multiply, and it works. Cool, there's a 0 remainder, and now my answer. If you thought you had the answer before, you did not, until you got to this part. And then, can you stop? Yes, you can, technically, because the last part is imaginary factoring. But I encourage that, so I encourage you to go the extra mile and say this is x plus something, and x minus something, and I am positive that you would need an I to make this work. So I and I. But some kids just robotically put in square root of 9, and what should they put? 3. Now 3i or I3, I'd take either one. Technically, usually we'd say 3i, but I would have taken either one. Okay, there we go. How many real roots did it have? 1. This one's the real one. How many imaginary roots did it have? 2. Total of 3 roots. Notice a 3 up here. All right, next is a thing called the rational root theorem. And it's the factors of the constant. Can anybody finish it? Factors of the coefficient. All right, see if you can do that for this. The factors of the constant, that's a squared, by the way, over the factors of the coefficient. You're supposed to give a list of all the possible factors. And I know some of you are like, but I'm just going to graph it. That's good. That's smart. You'll know which one works. But the question is going to say, what were all the possible roots? You can't get that from the calculator. The calculator will only give you the real one. The list of possible roots is, what are the factors of the constant? 1. What are the factors of the coefficient? 2 and 1. And then it's plus and minus of all that. So then I actually divide them. What's 1 divided by 2? 1/2. What's 1 divided by 1? 1. And I put a plus and minus in front, and there we go. I'm going to just, for good measure, put a plus and minus in front of each one. And I have plus and minus 1/2 and plus and minus 1. Anything else? How many answers is that? There's 4. Now, if you wanted to, could you just do synthetic on all of them and see until you found one that worked? Yes. Now, one more thing. These are the possible roots. Is it possible that none of them work? Yeah, think about this. Does everything factor? No, not everything factors. All right, so this one happens to work. And so I'm going to ask you to use synthetic. No, I'm going to actually, use your calculator and do it the smart way. Tell me which of those 4 possible roots it is. Is it -1/2? Is it +1/2? Is it 1? Is it -1? If you'd rather, you can use synthetic on all 4 things if you don't want to grab a calculator. I'm fine with either one. I'll pause for a second. All right, so when you graph this thing, it appears to either touch at one of these things, and I believe it's touching at +1. Or no, if I remember right, it was -1. -1? All right, -1 apparently would work. I'm going to check it. -1. Now, couldn't you just say, I used my calculator and the answer is -1? No, because they're going to say, then factor it. Now, your calculator can't factor. Calculator can tell you what worked, but you have to do the factoring. So everybody right now, try this. Use synthetic, actually factor it. I'll pause for a second. You do that. Okay, so you drop the 2, multiply, add, multiply, add. Oh my gosh, it worked, because there's a 0. X plus 1, 2x minus, no, plus 1. And there we go. So, now do you have anything else on this test? Oh yes, there's other things. But you're going to get a really extensive list in the review worksheet. I want to give you some time. So the alarm went off, so we have about 10 minutes left, so 11 maybe. So this is the part where you should work on that review worksheet. You are turning it in tomorrow. So if you needed any incentive to get it done, I am collecting those and grading them myself for each person. So get them done. Okay, so you're going to Dropbox them tomorrow. Yes. No, if you already have finished it, yay for you. But it was not due until tomorrow. So, yes. Okay, individual question. Yes.
Big Bird from Sesame Street.
Okay, Big Bird. I got to stop the video. Thank you very much for listening, and good luck on your test. Yes.